Assalamu alaikum. Now we can move to another application of dimensional formula, that is checking correctness of an formula. ये क्या होता है, पहले पहले हमने जो फर्स्ट एप्लीकेशन था वो द कन्वर्ट वन सिस्टम ऑफ यूनिट्स इनटू अनदर. We have discussed in detail. We have converted the units of Newton, this force, and we have also converted the units of work, joule into urges, and force into dyne. We are discussing in details in two classes. Now, in today's classes, the second use of dimensional formula. This is also important. We can use, with the help of this second application, we can see the checking the correctness of a formula. This is based on what? This is based on the principle of homogeneity. वो क्या होते हैं? This checking correctness formula based on the principle of homogeneity. What does principle of homogeneity states? It states that dimensions of all the terms on the two sides of the equation must be same. जितने भी terms equation में हैं, हर एक term के dimension same होने चाहिए. It states that what is principle of homogeneity? It states that the dimensions on the two sides of the equation must be same. It states that the dimensions on the two sides of the equation must be same. This is based on the principle of homogeneity. जितने भी terms equation में इनके dimensions same होने चाहिए. We will see that the equation is dimensionally correct. We will see this equation is correct or wrong. How can, suppose we can take an example of, suppose this is one equation of motion. Suppose v is equal to u plus at. You know this. इसके एक टर्म ये है, दूसरी टर्म u है, तीसरी टर्म at है. ये टर्म है. We will see how it is dimensionally correct, whether the equation is dimensionally correct or not. What we are doing, we are seeing the dimension of each term. Suppose we can see velocity. Velocity किसके बराबर है? We know that velocity is equal to, it is final velocity equal to distance divided by time. Distance, the dimension of distance is L, time is L divided by T. It is dimensional means m0 L1 T raised power minus 1. Now U, it is another term. It's again distance divided by time. Distance L divided by T. It is dimension becomes m0 L1 T raised power minus 1. Now another one more term, that is AT. It is not a single T, it is AT. A and T. Acceleration is velocity divided by time. Acceleration is velocity divided by time multiplied by time. Time and time cancel. Velocity is again distance divided by time, so go L divided by T. That means dimensions of AT is m0 L0 T, L1 T raised power minus 1. When we look dimensions of velocity, it is we can substitute in equation first, or substituting in equation first, we can get the dimensions of each term. When we substitute in equation v is equal to, instead of v I can write m0 L1 T raised power minus 1 is equal to, instead of u I can write again m0 L1 T raised power minus 1 plus 80. Instead of 80 I can write m0 L1 T raised power minus 1. When we look all the three terms, the dimension of v is m0 L1 T raised power minus 1. The dimensions of m0 u is also m0 L1 T raised power minus 1. Dimensions of at is m0 L1 T raised power minus 1. That means each term involving in the equation must have the same dimension. That means we say this is correct equation, this is dimensionally correct equation. We can take one more example here. Suppose I take the example of one more equation of motion, that is s is equal to ut plus 1 half of at square. First of all, name this equation first. Dimension s is distance, its dimension is simply length. That means its dimensional formula becomes dimensional formula of s is equal to, it is m0 l1 t0. Now ut, u is the initial velocity, velocity is distance by time, distance divided by time multiplied by time, time and time cancel, it is again distance is l, that means dimensions of ut is m0 l1 t0. Now we can say at square, we cannot take 1 by 2, 1 by 2 numerical value uska kuch nahi, we have to do nothing with the numerical, we have to see the value of at square. We have to find out that we know that the dimensions of constant is 0. Iski koi, these are some values which I have already discussed this term, that there are some quantities which have constant but they do not have dimension. It has not any dimensions. The dimension of at square. Acceleration, we know that acceleration is velocity divided by time into t square. Velocity is again distance divided by time, go t into t already time distance, velocity is distance by time, एक time है और t square, ये और ये cancel, it is equal to l. Therefore dimensions of at square is equal to m0 l1 t raised power 0. When we substitute in equation, first we can get s is equal to m0 l1 t0 ut m0 l1 t0 already discussed, at square m0 l1 t0. That means when we see each term is having the same dimension, we say that equation is dimensionally correct. One more example we can take here, which is also in our syllabus. V square minus u square is equal to 2a. I hope you have got it. You will do it yourself now. If v square is equal to velocity is equal to distance divided by time, distance go l divided by t का whole square, l divided by t whole square, it is equal to l square t square. That means dimensions of v square is equal to m0 l 2 t raised power minus 2. Similarly, u square, u square is again distance divided by time, which is initial velocity, distance divided by time का whole square, l divided by t का whole square, it is equal to dimensions इसके क्या बनेंगे, सेम बनेंगे. Dimensions of u square is equal to m0 l2 t raised power minus 2 u square के. अब हम as की लेंगे, a and s. A means acceleration is velocity divided by time into distance is l. Velocity is again distance divided by time, और एक time नीचे ही होगा into l, it becomes l square divided by t square. You know this, l square divided by t square. Dimensions क्या बन जाए, dimensions of as is equal to m0 l2 t raised power minus 2. When we substitute in the equation, above equation, name this equation first, v square, instead of v square we write m0 l2 t raised power minus 2 minus, instead of u square we can write m0 l2 t raised power minus 2. Instead of as we can write m0 L to t raised to power minus 2. That means when we see towards the equation, every term is having the same dimension. Because we see that dimensionally the equation is correct, we say this is a correct. Go with the help of dimensional formula, we are able to see whether the equation is dimensionally correct or not, but is a correct equation or not. But what our principle it is based? It is based on the principle of homogeneity. What is principle of homogeneity? It states that principle of homogeneity states that dimensions of all the terms in on the two sides of the equation must be same. जितने भी terms है इनके dimension same होनी चाहिए. I hope you have got this. This is the application. We are doing also application of these uses of. We are discussing the use of dimensional and one use conversion of one system of units and another. We have seen its application also. Checking the correctness of a formula, we are also we have seen its application also. We have taken different equation of motion. We have seen here that each term in the equation must is having the same dimensions. Thank you very much. Hope you have got it.